Hi everybody. There's one more example that I had hoped to have time to work through in class today that I didn't have time, so let's work through that now. If you print out the notes from Blackboard, you'll see this problem in your notes. But if you don't print out the notes, it's still a valuable problem to see how it's set up. So here's what we've got. A little company makes outdoor furniture. They make benches, picnic tables, and fancy Adirondack chairs like the one on your screen. Super comfortable. But to be efficient, each shift has got some limitations on how much of each job they can do during each individual shift. Some people are better at certain jobs than others, and you've got equipment limitations and whatnot. So here's what we've got. For each bench, it takes 20 minutes to cut out all the necessary pieces. It takes 30 minutes to assemble it, and then 40 minutes to do a thorough job of painting it. The tables take 15 minutes to cut out, 30 minutes to assemble, and a little bit longer to get them all painted. The chairs, though, well, those take a long time to cut out. A lot of curvy pieces there. 75 minutes, 90 minutes to put one of those together, and 120 minutes to get it all painted up. Here's the problem. We've got limitations. There's only 4.5 hours of cutting availability per shift. Okay, we can't exceed that. There's also 6.5 hours of staff available to do the assembly, but there is quite a bit of time available for painting. There's 10 hours. So we need to figure out how many benches, how many tables, and how many chairs we should make during each shift in order to maximize the available time for each process. So, the first thing we have to recognize here is that our time values, since we're talking about minutes for each of the individual steps, we should turn our limitations into minutes as well. So 4.5 hours is 270 minutes, 6.5 hours is 390 minutes, and 10 hours is 600 minutes. The other thing we really need to do here is we need to name our variables. So let B be the number of benches, T be the number of tables, and C be the number of chairs. Nothing fancy there. Now, as you can guess, our cutting time is going to be divided up amongst the 3 different pieces of furniture. It takes 20 minutes for each bench that we make, so 20B will contribute to our cutting time. 15 minutes for each table, 75 minutes for each chair, and the total time spent cutting pieces for these 3 pieces of furniture shouldn't be any more than 270. We want to use that all up, so we'll say it's equal to 270. And that's basically pulled right off the top row of our table. And then of course the same thing is true for assembling and painting as well. 30B plus 30T is plus 90C equals 390. And our bottom row, 40 minutes for each bench, 60 minutes of painting for each table, 120 minutes for each chair, and that's got to be 600 total minutes. So there's our system of equations. Now, I wouldn't blame you for wanting to be excited and jump in and solve for A, B, and C right off the bat, but you can make your life a little bit easier. There's an awful lot of zeros in that system. So we can clean that up a little bit. All those top coefficients are divisible by 5. Everything in the middle row we could divide by 10, and in the bottom row everything is divisible by 20. So that doesn't change our equations, it just simplifies the way they look. And if we do that, divide the top row by 5, we get 4B plus 3T is 15C. Divide the middle row all by 10, and the bottom row all by 20, and we get those new values. Now, of course, then you have a system to solve, and you can use the techniques that we've developed to do that. I won't go through the process of solving. That would be one long, boring video. But if you do solve, you should get B equals 3, T equals 4, and C equals 2. Which means the company should make 3 benches, 4 tables, and 2 chairs during each shift. And that is the end of that.